Key features of exponential graphs or exponential functions. First of all, exponential functions have the form y equals a times b to the x plus k. Now, in this form, a is your initial value or your starting value. So I want you to think of our typical example is a bacteria population, and a bacteria population will either double every hour or triple every hour so that there's more and more bacteria. So A is going to represent how many bacteria we started with. If we started with 2 bacteria, then the A value would be 2. Now, B is your growth rate. This could also be called your decay rate, which is more importantly your common ratio. Now, if your bacteria are growing, you're getting more and more and more, then that's going to be your growth rate. So let's say your bacteria triple every hour, then the B value would be 3. But let's say that your bacteria are actually dying and you're getting less and they're going down by like half every hour, then your B value will be 1/2. And then your K value is your horizontal asymptote. And this is actually a number that your bacteria approach but never actually get to, which is most commonly 0, but we'll take a look at it on our next slide. So the parent function of an exponential function is up here on the left, and it's y equals 1 times 2 to the power of x. Now, do you notice that on this one, there's no k? So your a value here is 1, your b value here is 2, but your k value here is that plus k, and it's not there, so your k value is actually 0. And we're going to look at how all of these things start to play out on this graph. Now, in order to graph this, we're going to start by making a table. So if x is -2, we're just going to evaluate our function and we're going to substitute in -2. So you're going to have 1 times 2 to the power of -2, which is 1/4. If we plot that, we would go -2 and up 1/4, which is really small. Then you're going to substitute in -1. So 1 times 2 to the -1 is 1/2, which would put you about there. When you substitute in 0, you get 2. Oh, I'm sorry, you don't get 2. You get 1. So then we're at 0, 1. When you substitute in 1, that's when you get 2. When you substitute in 2, you get 4. And when you substitute in 3, you get 8. Now, before we actually connect these dots, the first thing we're going to notice is this is not making a line. But I'm not going to connect them yet because there's a couple of things we have to consider before actually drawing what this makes. So if we come down here to the bottom of our key features, our first one is our y-intercept. Your y-intercept is where the graph hits the y-axis. So if I kind of consider my y-axis, which is sitting right here, it hits right here at this blue dot, so my y-intercept is 1. Now, my x-intercept. At the moment, if I'm taking a look at this, my x-intercept is where I hit the x-axis. And if you're looking at the x-axis, I don't see an x-intercept right now. So let's keep that in mind and move on. So the next one is your growth or decay rate, or your growth or decay factor. And that you can either find by looking at your function, which is your b value, or by looking at your table. So if you're looking at your table, how do you get from 1 to 2? You multiply by 2. How do you get from 2 to 4? You multiply by 2. How do you get from 4 to 8? You multiply by 2. It works with the fractions as well. If you take a fourth and you multiply it by 2, you get a half. And if you take a half and multiply by 2, you get 1. So that's where that 2 pops up, and it's your common ratio. In this case, it's your growth rate because it's growing, it's getting bigger. Now, your domain is all of your x values. It's been a while since we've done that one, but for your domain, I have our yellow highlighter. If we take a look at these blue dots, which right now they are just blue dots, we haven't connected them, we have to figure out how far left and how far right this thing goes. And then when we do our range, we have to figure out how far low and how far high this thing goes. In order to do that, I'm going to move over to our k value, and I'm going to consider that idea of a horizontal asymptote, whatever that is. Okay? Now, as I go through my table, I go from 1 to 2 to 4 to 8, and my numbers keep getting larger and larger and larger. Well, what about if I go the other way? Instead of multiplying by 2, I could divide by 2. So if I did this again, and I took a fourth and I divided by 2, that would be an eighth. So that would be really small there. If I did it again, that would be a 16th. And that would be really even smaller there. If I did it again, that would be 1 out of 32, then 1 out of 64. Do you notice we keep getting smaller and smaller and smaller? But the question is, will we ever get to 0? Will we ever hit the x-axis? And the answer there is no. If you keep taking half of something, half of something, half of something, you're never actually going to take all of it and get rid of all of it. So the idea of a horizontal asymptote is it's this line that I'm approaching, which in this case is 0, but you're never, ever, ever going to touch. So when you draw this graph and you connect your dots, it gets really small out here. So we just kind of draw a line that's next to 0 but not touching it. And then it gets really, 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 really big going that way. But the key is when you draw your graph, do not go below the x-axis. It never goes below the x-axis. So our x-intercept, there is none. It just gets close to it. Our domain now, I'm going to go back to domain. How far left? This thing goes the whole way to the left. Okay, that blue line keeps going. How far right? There is an arrow. It's going up, but it's going out as well. It will go to 4 and 5 and 6 and 7. We just can't see it. So your domain, we can write this 2 different ways, is all real numbers, or you can tell me it goes from negative infinity to infinity. Then we have our range, how far low, how far high. Well, low, it doesn't come down here, because remember we said it kind of stops or gets really close to the x-axis, but it never touches it. So this would be 0, and then it gets bigger and bigger and bigger and bigger and bigger and bigger. So that means that y is greater than 0, or you can write that as a parenthesis 0 to infinity with another parenthesis. And then last but not least, our horizontal asymptote. That is that red dotted line that I put on the graph. That is the line that it gets close to, but it never touches, and that is at y equals 0, which is the x-axis.